Welcome to Abstraction Academy. In today's lesson, we're diving into one of the most important ideas in artificial intelligence, neural networks. These systems are what allow machines to recognize patterns, make predictions, and even understand language. By the end of this video, you'll understand how neural networks work, how they learn, and why they're the foundation of modern AI. Neural networks are inspired by the human brain. Our brains have billions of neurons connected by synapses, tiny pathways that strengthen and or weaken as we learn. In a neural network, we simulate the same concept with layers of artificial neurons. Each neuron processes information, passes it along, and gradually learns what pattern matters most. It's not biological, it's mathematical, but the goal is similar, to learn from the experience. You might not realize it, but neural networks are all around you. They're what help self-driving cars detect obstacles, what make Face ID work on your phone, and what power chatbots like ChatGPT. They recommend your favorite videos, analyze medical images, and even translate languages in real time. Nearly every major advancement in AI over the past decade, from image recognition to voice assistant, depends on neural networks. Let's take a look inside a neural network. It is made up of layers. The input layers receive data, for example the image's pixel. The hidden layers process the data by combining numbers and finding patterns. Finally, the output layer gives a result, maybe predicting that the image is a cat. Every connection that happens between neurons has a weight, a number that represents how important that input is. These weights are what the network adjusts as it learns. Each artificial neuron performs a simple operation. It takes several inputs, multiplies each by its own weight, adds them together, and includes a small bias term. The result is passed through something called an activation function, which decides the neuron's output. In short, it's like a tiny decision maker. One neuron alone isn't smart, but when you connect thousands or millions of them in layers, they can learn to solve very complex problems. Activation functions are what give neural networks their flexibility. Without them, the network could only learn straight-line relationships, very limited. The sigmoid function squashes numbers between 0 and 1, making it useful for probabilities. The ReLU function, short for rectified linear unit, keeps positive values and removes negatives. It's simple but powerful and used in most deep learning models. The tanh function maps values between -1 and 1, helpful when centered data works best. These functions make neural networks capable of capturing complex, nonlinear patterns. Now let's see how a neural network makes predictions. When you feed data into it, the information flows forward from the input layer to the output layer, a process called forward propagation. Each layer applies its weight and activation functions, transforming the data step by step. At the end, the output layer gives a prediction, for example, that an image is 98% likely to be a cat. Early in those training, the predictions are often wrong, but that's when learning begins. Backpropagation. After making a prediction, the network compares its answer to the correct result. The difference between them is called a loss, which measures how wrong the model was. Using an algorithm called backpropagation, the network sends that error backward through all the layers. It then adjusts the weight slightly to reduce the error time next time. This cycle of forward propagation, loss calculation, and backpropagation repeats thousands of times until the network becomes highly accurate. That's how machines learn, not by being told what's right, but by improving through feedback. Here's an example: recognizing a cat. Let's make it with a concrete example. Suppose we want a neural network to recognize cats. We feed it thousands of images labeled cat and images labeled not a cat. Over time, the network learns to notice patterns, maybe the shapes of the ears, the position of the eyes, the texture of the fur. Each layer learns a different feature, and together they identify what makes a cat a cat. When shown the image it's never seen before, it can still predict with confidence that that's a cat or that's not a cat. That's the power of learning patterns from data. Neural networks versus human brains. Even though neural networks are inspired by the brain, they're very different. Our brains have 86 billion neurons that communicate through chemicals and electricity. Neural networks might have a few thousand or a few million artificial neurons that communicate through numbers. The most ever known to be recorded was 1 billion neurons in a neural network. Brains can reason, imagine, and feel emotions. Neural networks can't. They only recognize patterns and make mathematical predictions. But despite being far simpler, they are still incredibly effective at solving certain types of problems faster than humans. As powerful as neural networks are, they have major challenges. They need massive amounts of training data and computing power. Training large models can take days, weeks, or even months and use significant energy. They can also learn hidden biases from their data, for example, favoring one pattern over another pattern because of unbalanced examples. And perhaps the biggest limitation, it's often hard to understand exactly why a neural network is made a specific decision. This lack of transparency is known as the black box problem. To wrap up, neural networks are the foundation of modern artificial intelligence. They've transformed industries from healthcare to space exploration, and they've opened doors to tools we once thought impossible. By combining simple mathematical operations with massive data, these systems can learn to see, hear, and interpret from the world around us. In our next lesson, we'll be taking this concept further and explore deep learning, how stacking multiple neural layers leads to even more powerful results. Thanks for watching Abstraction Academy, where we inspire the next generation of innovators. Good luck on your quiz.